Hello viewers, welcome back to my channel. In today's video, we will be talking on how to write the SAS code to create the ADTTE dataset. Creating time-to-event dataset can be a difficult programming task, especially when interim data analysis is going on. This is usually because the event data itself are captured in more than one place in the CRF form, and sensor date may be difficult to obtain. For example, perhaps the event of interest is death. We may have to search the adverse event CRF form, the study termination CRF form, the clinical endpoint committee CRF form, and perhaps a special death event CRF form just to gather all of the known death events and dates. For subjects who did not experience the event of interest, we may not have a study termination form to provide the censoring date. So we may have to use some surrogate data to create a censoring date. The example which I am using in this video is the simplest example of what an ADAM basic data structure time to event data might look like when the event of interest is seizure. In this example, we assume that there is a seizure event form that collects whether a subject has a seizure and the date is or date on which the seizure occurred. And we also assume that we do not need to search other data forms such as the adverse events for seizure events. So let's get started and move to the SAS code, which we can write in this scenario. So right now, I am creating a CEDM and EX data first for this example. So in this first step, what I'm doing is I'm inputting the sample seizure data, that is this clinical event domain. So we start by creating a dataset called the CE here, which represents the clinical event data in SDTM. We define the labels for key variables like subject ID, CE term, CE press, CE occur, and the CE start date. The clinical event term is fixed as seizure here as the CE term, and we are populating the CE press as Y. Using the input and data line statement, we are generating the data for CE, which is having for 4 subjects. Let's run this and see the output. So you can see that we have the respective columns created, and we are keeping only the columns which we need in our data. In this example, the subject 101 has a seizure, which is marked as Y, and which is happening on 5th of May 2004. While the subject 102 have no seizure, while subject 103 have missing data. In this second step, we are generating the DM dataset for the set subject, and we are having the RF ENDTC only present in our DM for this example. So in this scenario, for subject 1, we have populated the RF ENDTC as the 5th of August 2004, and while subject 4 for 104, it ends on 20th of August 2004. So let's run the DM as well. Here we have the data created for these two variables from DM. Similarly, when we are working on EX data, we are only keeping the start date, exposure start date, and the subject ID from the EX data as well. And to note here is again that for subject 101, the treatment started on 1st of January 2004, and whereas the subject 104, it started on 9th of January 2004. So let's run the EX as well. So here we have these two variables also created. The point here to note here in these 3 data steps is that the source SDTM dataset, CE, DM, and EX for this example are minimalist and do not contain all the variables that will be needed for valid SDTM domains. The variable here are provided to show the calculation in a time to event dataset. The next step is to create the time to seizure analysis dataset. In this step, what we are doing is we are building the ADTTE dataset, which follows the ADAM time to event structure. We have merged the DM, EX, and CE datasets by subject ID. We have defined a parameter which by the value of param, which is time to seizure in days. Then depending on seizure occurrence, we calculate the analysis variables such as in first case, the event occur, that is when the CE occur is Y. In this case, the AVAL is calculated as the difference between the seizure date and the treatment start date plus 1. And the censoring variable, which is the CNSR, is set to Y, meaning not censored. That means that the event has occurred. And the ADT is assigned the actual seizure date, which is coming from the CE start date. In the second case, when event did not occur, that is the CE occur is N, in that case, the AVAL is calculated as the difference between the end of study date and the treatment start date plus 1. The censoring variable is set to Y, meaning the subject was censored, that the event did not happen within the study period. The ADT is assigned as the end of the study date. We may also apply labels and formats to make the dataset clear and analysis ready. So let's run this dataset and see the resultant AD seizure dataset. So if you see here that we have generated the dataset where we are having all the variables which we have in our merged dataset, as well as the variables which we have created in this data step. Please note that as per CDISC ADAM standards, the analysis dataset name starts with AD in the dataset name. So CDISC ADAM parameters variables like param, ADT, sensor, and AVALs are created here so that we can see how the time to event variables are translated into the ADAM basic data structure. It is interesting to note that the actual time to event is stored in variable AVAL because that is the analysis value. Keep in mind that the data in this example are simple. Note that if there are many seizures for a subject, you would probably have wanted only the first of the time seizure presented. So in this way, right now, this is the seizure dataset we have created, and from the study point of view, you can keep the required variables in your final dataset when you are creating the ADTT dataset, and drop the other variables which are coming from the input dataset. So if we use the proc print in the next step, we are keeping the variables which we want, and we are also ordering we are also using the where statement. We are making sure that we are keeping the variables in a particular order in the output dataset. So if we print this data, this is the way you will have, and you will have the subject ID, PARAMCDs, which is time to seizure in days. Right now, we have the AVAL, we have the censoring value, ADT, and the other variables which we are coming from the input dataset. But as I said, that we can drop these when we are creating the ADTT dataset. And if right now what I'm showing you is the intermediate dataset, which can be used to create the final ADT dataset. So in this way, you can create the ADT dataset for any type of PARAMCDs in your study. That's all for today. Let me know in comments if you want me to cover any specific topic. Thanks for watching.